Get comfortable, and here we go. The second one begins by saying that x plus 4 squared plus y minus 1 squared equals 32. Well, that tells us a couple things. First of all, it tells us that the x value of the center will be negative 4, and that the y value of the center will be positive 1, and the radius will be the square root of 32. Let's do this quickly. The square root of 32. Most people think 4 and 8 when they think of 32, but it's probably smarter to think of the square root of 16 and the square root of 2, because the square root of 16 is a perfect square. Therefore, we know that the radius will be 4 square root of 2. So once again, x will be negative 4, y will be positive 1. So let's plot it, and then we'll worry about making our circle. So here's the origin. It says again, x is negative 4. So that's 1, 2, 3, 4, and y is positive 1. Therefore, our center will be right here. And again, we said our radius will be 4 square root of 2. So the smartest way to do a 4 square root of 2, it's tricky at first, but you guys all know it's 1, 2, 3, 4 this way, 1, 2, 3, 4 this way, and this distance here, the radius, is going to be 4 square root of 2. So now, we take our compass, we put the point at the origin, we line up the point on the edge, and if you're like me, you drag your paper rather than your compass, and you construct your circle. Alright, interestingly, we've got one of the 4 points right here. The other of the 4 points will be directly below it, another one directly to the left, another one directly above. If your construction is perfect, you should have perfect intersections. But key is that what we have here is clearly a square. Okay, so the 4 points equal, well, I'll go with this one. This is 0, so it's going to be 0, 1, 2, 3, 4, 5, 0, 5. It's going to be 0, negative 3, 1, 2, 3, 0, negative 3. It's going to be negative 8, 5, negative 8, 5, and negative 8, negative 3. Once again, 0, 5, 0, negative 3, negative 8, 5, and negative 8, negative 3. Next it says to connect the 4 points. So that's exactly what we're going to do. We're going to create a little square. This kind of goes back to how we first discovered that when you graph a circle in the coordinate plane, the 4 points always form a square. Okay, so there you go. We've got a square. It also says to construct tangents to the 4 points. So that's interesting. Let's remember that a tangent has to be perpendicular to the radius. So a way I can make this perpendicular is if this counts 4 up and 4 to the right, I'm going to count 4 down and 4 to the right to help construct this tangent here. As you can see, this tangent is perpendicular to the radius. I can do the same here. It's kind of easy. If you just line the boxes up, you can tell where your tangent lines will have to be set up from. That one should have been longer. Sorry. Make it a little longer. This one as well. We'll set up just like that. And the 4th tangent line will come through just like this. And we have our circumscribed square. So we have our circle, our inscribed square, and our circumscribed square. Okay, so the area of the circle equals, well, this could be easy. We can just pluck it right out of the equation. If it's 32, then you know what it's going to be is 32 pi units squared. You could also take the radius, 4 square root of 2, square the 4, that makes 16, square the square root of 2, that makes 2. 16 times 2 is 32. So therefore, yes, 32 pi units squared. The area of the small square, well, this seems hard except for you remember we're on a graph, so it's kind of easy. You just count. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 8 is 64. You could also, of course, go back to the circle, replace the pi with a 2, and do it that way. So if we replace the pi with a 2, we'd have 32 times 2. 32 times 2 is 64. And that's probably the best method to use for the area of the large square. The large square is circumscribed, so its ratio will be 4 over pi. And all that means is that we replace this pi with a 4, so we get 32 times 4, which is 128 units squared. So now we've got the area of the large square as well. Okay, the last question it says, this is just, I think, a little bit extra fancy. It says, shade everything but the circle. Find the total shaded area. So basically what we're going to do is we're going to shade in these sections here. It says everything but the circle, but I would interpret something like that to mean that I do shade the inner square. I just leave out the circle aspect. So the best approach for this would be to sort of say, this question is asking us, what is the area of this big square minus the circle plus the small square? Right? We have the big square with the circle removed with the small square added. So all we really need to do here is plug in our values that we already have. So the area of the large square is 128. So it's going to be 128 minus the area of the circle, which is 32 pi, plus the area of the small square, which would be 64. Now, I'm not a big fan of converting. You can if you want, but that's not really what this is about. It's really about conceptual. So we have two regular numbers, which we can combine, and a third number which we can't combine, so we'll just leave as a subtracted term. So 128 plus 64 is 192, because those are your regular numbers, and those would be added, minus 32 pi. And that's your actual answer. 192 minus 32 pi units squared. And we've got it. So that's it for number 2. Alright. Heads up, take a breath. Yeah, it's taxing for me too. Again, rewind if you need to, if it's a little confusing. Feel free. This isn't about trying to get it the first time, it's about getting it, period. So when you've got it, that's when it's time to move on. Me right now, I'm going to move on.